idea of automata theory that you have states and you jump from state to state, that is okay for small systems, but that's not applicable to large systems. So that was our starting point. And what came out, I will show you not in an abstract framework, but in an example. And the example is not really taken from cloud computing, but I think you will immediately see that it can apply to anything else. So the example is a bank branch, and we have 4 components there in the bank. One is the clients, and the other ones I will tell you in a minute. So what does a client do when he comes to the bank branch here? He enters the bank branch. C and S are variables. C is a variable for the customer, S is a variable for the service he needs. So the customer enters with the service in mind he needs. The help desk will tell him to wait, and then he gets either the notice that no expert is available for his service, or he gets the information that an expert is available, and then he should go to a special room. So what you see here is this box, and on the surface of the box, you see the interface of the system. And interface is a fundamental aspect. So here the interface on the left, it consists on what we in Petronets call transition. That is a relatively simple interface. On the right, you have a transition here. You have places here and here, and even you have arcs that go in and out of the component. That is a very liberal way of interface, and we can cope with this in a very nice way. So here are the consulting rooms, and you will immediately understand what happens here. So if a client comes into the room, and if an expert comes into the room, they negotiate, they start, they end negotiation, and then they go back. That's all the room is doing. Here we have the experts themselves, and here we have a kind of a modeling technique that I want to explain a little bit in more detail. That is, we want to model the available experts. So how can you model the available experts on this schematic level? And the point is, you can do it as follows. You have a symbol X that is to be instantiated in a concrete world by a set of experts. And now the problem is, on this place of the Petronet, there should not be one token, which is the set of experts, but there should be many tokens. So each expert should be a token. And that is described by this element function. So that means you instantiate the expert symbol, and then the element function tells you that all the experts are as single tokens herein. So what does it mean if there is an expert and he gets the request for a service, then he goes to the room, and eventually he comes back and he finishes his services. So the last component are the administration. And here again, we should look a little bit more close what happens here. So what we have, in fact, in this kind of inscriptions is we have altogether five sorts of components: clients, expert rooms, admins, and services. We have constant symbols that you have seen here, and you have already seen the expert symbols for the list of available experts that you find here again. Here you have the same story about the rooms, and here you have the same about the administration. So a set of administrators, a set of rooms, a set of experts is modeled here. And altogether, in addition, we have a function symbol that is here, or the element is